For question 5, we have solve for the integral of cosine x cosine to the 5th of sine x dx. With this problem, we can use u substitution. We can claim that u is equal to sine x, giving us du is equal to cosine x dx. Now we just substitute in for the integral. We get the integral of cosine to the 5th u du. Now we can split up cosine to the 5th into cosine to the 4th and cosine u, giving us integral of cosine to the 4th u cosine u du. We can also split up cosine to the 4th into cosine squared u all squared, giving us integral of cosine squared u squared cosine u du. Now from a trig identity, we know that sine squared x plus cosine squared x is equal to 1. And if we solve for cosine squared x, we can see that cosine squared x is equal to 1 minus sine squared x. Then we can use this in our integral, and we will get the integral of 1 minus sine squared u squared cosine u du. From here we can do another substitution, and we can use v. We can claim that v is equal to sine of u, giving our dv to be equal to cosine u du. Plugging v into our integral, we now have the integral of 1 minus v squared dv. When we FOIL this out, we have that 1 minus v squared times 1 minus v squared. We get 1 minus 2v squared plus v to the 4th, which then gives us the integral of 1 minus 2v squared plus v to the 4th dv. From here we can integrate normally, and we get v minus 2v cubed over 3 plus v to the 5th over 5 plus c. We can now plug in our u's, and this will give us sine of u minus 2 sine cubed of u over 3 plus sine to the 5th of u over 5 plus c. For the last step, we have to plug in our x's, and we will get sine of sine x minus 2 sine cubed of sine x over 3 plus sine to the 5th of sine x over 5 plus our constant of integration, c. And this is our final answer.